Hello everyone, my name is Yupang. Today I will introduce our group project. Our group project's name is Ranking of Quality of Life, which means that we will give a ranking of specific areas by using big data and spatial data. Our group number is 12, and my partners are Jiahao Ge, Chu Liangzhang, and Yu Xidong. Here is our outline. I will first introduce our project idea, and then talk about what we have done during the project. Then my partner Yu Xidong will talk about how our application works. In our project, we propose to implement a spatial data management application combining with big data processing technologies to rank the quality of life in certain areas. When a user inputs an area, our backend will split this area into small pieces and return ranking results on each of them to the front end with details as written. In our system, we store our spatial data and other related information data such as POI, parks, air quality, and hospitals in HDFS. Then we build spatial index on these spatial data to accelerate query processing like range query. Second, achieved. We collect spatial and related data such as the hospitals, POIs, which means the point of interest, parks, air quality, and then we pre-process and clean our data. Then we implement the range algorithm by using GeoSpark, implementing the query backend, combining Spring Boot with the Spark. And we also implement a web search interface by using React and Google Map API. Finally, we add functions that allow users to modify ranking formula weights. About the data preprocessing. Well, in order to parse data conveniently, we need to pre-process data first so that it can meet the requirement of backend interface. Here, for example, the POI data. It has many unnecessary features here like this one and this one. And also, its latitude and longitude are the radian version, which is now the degree version required by the backend interface. So we need to convert the radian version into degree version and also remove these unnecessary features. Our other datasets follow these rules as well. Next, about the ranking. We first create index by using R-tree, and then we separate search area into 3 multiplied 3 small pieces, like here. Then we implement spatial range query. For example, we do a range query between a point RDD and a polygon RDD to get the result. Next, we get the number and grade of each indicator, and then we will apply our ranking formula. Here, the formula is to calculate the result. Here, each feature has its own weights, and the users can also change these weights. Finally, it will return each indicator's ranking grade to the front end. Here is an example of our front end. You can see that there is 9 rank here. To see more details, my partner Yu Xidong will show how our application works.
Hi, my name is Yuxi Dong. I will be demonstrating our web application. So our web application is very simple to use. So here we use Google Map to display the map, and you can zoom in or out. So right here we're in the riverside. Um, when you are in this area, we can search and rank the best place to live. We just click on search. You can see here there is a ranking based on the data from backend. We can see in these 2 areas we have the best quality of life, and we can also demonstrate here. Let's switch to this region. If we search inside of um, this region, we can we can see that it makes sense because the region beside around the Beverly Hills has the highest ranking, and the region in the seas has the lowest ranking. We can also input our custom search formula into the search box. The WHOS means the weight of the hospital, weight, and the weight of point of interest. So if we weight really high of the hospital, this is the result. If we change the hospital's weights to 0, we will see a different result in this region. So that's all of our presentation. Thank you.